I'm Albert. I'll be giving you the,
Great introduction!
So yes, keep questions at the end. There's going to be a lot of stuff, so don't make me run out of time. Please. Thank you. All right, so what is Git? It's version control, it's fast, it's distributed, it's free and open source. I'm not going to bore you with all the details at this point. So yeah, what's a repository? So in Git, a repository is a directed acyclic graph of commit nodes. So a directed graph. So yeah, here's an example of a directed acyclic graph. So a graph is a set of nodes connected by edges. A directed graph is a graph with directed edges, note the arrows. A directed acyclic graph is a directed graph without cycles. Notice how there's no cycles or arrows in here. So the Git graph. So Git is a DAG. The commands that Git offers you perform operations on the DAG. So here I have a selected history from the Bootstrap repository. Notice how the latest commit is at the top, and it has a label called head and master, and these are just pointers to commits. So now let's dive into it. So Git init creates a blank repository. So Git init, and so if we do git status, which just tells you, sorry.
Good job.
So if we do git status, we can see that it's just initial commit. If we do a git log, which tells you the past history, bad default revision head, showing that it's a blank repository. So, and as I described, it's pointing to nothing. So, what is a commit? So again, another commit from Bootstrap. So at the top we have the commit hash, which is generated from the rest of the commit as its identifier. We have author date and time from when the commit was made. There's the content of the commit as file and not shown here is the pointer to the parent commit, which is the whole arrow thing from the graph earlier. And so, staging area. So I'm just gonna make a quick note. So like, I'm gonna have the history over here. The latest commit's always gonna be the left. So in case that's confusing. So we start with, so in Git, when you have a Git repo, there's your file system, which has the files in your repository. There's a staging area, which you put your changes in before you make a commit. And then you have your old commits from before. I guess you can call the staging area a meta commit, because it's just like, yeah, we'll just go into that later. So yeah, what git add does is it takes changes from the file system and adds them into the staging area. So let's first make a new file. File.text. I am a file. This is a file for stuff. Very descriptive stuff, totally useless. Yeah, so now we do git status, we see that there's no red.
Yeah, if you wiggle the projector, the quarters will show up, maybe.
No.
You don't need that channel.
Well, all it says there, untracked files, file.text. I'm not doing that.
That's a useless channel.
There we go. Now you can see red.
I think you're sort of
So, now that we have that file, we want to add it to the staging area, so we do git add file.text, and now it's in the staging area. How do we know? Git status, bam, it's there. So git commit takes the changes from the staging area and makes them into a commit. So like, yeah, so let me just demonstrate that again. Git commit. And so now it'll ask you to make a commit message. So A few other notes about git commit. Please don't use git commit -a, and similar note as don't use git add -a. It's important to keep only related changes in one commit. And yeah. And if you use git commit -a, you have no idea what you're committing. And so like, that's generally considered a bad thing. Yeah. Laziness is bad. Stop. So, yeah. So, commit messages. Don't use git commit -m with the message in there, because the same it'll like try to force you to make short messages. So, like generally, you want to start with a verb, make it present tense, succinctly say what you did, show, and yeah. So, for examples of good commit messages, I guess I'll just pull this up.
Pull up anything works ever done.
I mean,
Oh gosh. The most recent pull request.
I mean, so like if you look at here, reorganize source file structure, update version, make naming more consistent, stuff like that. That is not the presentation I'm looking for. All right. So, yeah, so as I was mentioning, it takes your staging area and brings it into a new commit. So now there's a new staging area, which is empty. Your old staging area is now a commit. And let me just show you how to do that again by going back to the demo. And so it's asking you for a commit message. I'm just going to come up with a garbage one. This is a commit. Please do not make commit messages like this. Everyone will hate you. So git status, again, there's nothing in the staging area as it says. If you do git log, there's your commit. And we lost red again. Oh well. Yeah.
Good job, bro.
You can stand up if you finish it.
That hurts. Hurt my feelings.
So another cool thing, git add -p. It lets you add specific changes from one file, like just part of a file. This is important because, again, earlier I mentioned you only want to keep the commits that you only want to keep the information that you want that's relevant to your commit in that commit. Like one change per commit is the general idea. And so, yeah, let's just dive into it. So I'm going to edit this file.
Switch monitors.
Right. Thank you. Here is some content. Here is some more content, and I'm going to add some stuff in the middle. Right? So we have that. So now we only want to add certain parts of that file. So we do git add -p file.txt. And so we want to. So if you go to edit mode, it'll just give you the diff, and you're just literally editing a diff. So the way to remove stuff that you don't want to add is just delete the lines. So that's what I'm going to do right here. Right here. So then I save that. It only took some of the changes. Let me show you the diff that's in the staging area. It's only adding the stuff in the middle. So now let's go ahead and commit that. More stuff. Please don't make these commit messages.
You're reading my cord.
I'm well aware. Okay, so let's just try that again, so that I have more history to work with later. So let's say this time I only want to add the stuff at the top. I didn't. So yeah, you do that, and then git commit stuff. And then we have finally one last thing at the bottom that we want to add. So notice I'm just adding more stuff to the staging area. So this is, I'm going to add both of these into one commit, even though I'm using different invocations of git add. So yeah. Right, so that's in the staging area. Wait, what? Yeah, whatever. Names.
Is that a good commit message?
No.
For all commit messages, prefer date for
So yeah, now we have a few commits in here. The original commit is at the bottom. More stuff and things from what I just did right now. No, it wasn't showing the red. So yeah, as I mentioned earlier, now I just threw it out. So we have your initial commit, you create the file, edit again, and so now it just brought master and head along over to this statement.
It's like a day. Almost.
So git clone, it literally copies a repository. So I'm going to go ahead and copy a repository. Actually, no.
With Linux kernel.
So I'm just for demonstration, just show that I'm copying a real repository. Right. So I have this repository, and then then it has a history again. So I'm going to go ahead and clone this into a new directory. Thank you.
I think you have to do some usernames like
Yeah.
Oh yeah, thank you. I accidentally hit thank. There we go. So if I go ahead and get log, see that we have the same history as was on there. And so git branch, one of the cool things about Git, you can make branches and merge them in really easily. So all it does is create a new branch, which is just, as I mentioned earlier, a pointer to a node. So go back here. So in this repository, I noticed there isn't a license. So I'm going to want to go ahead and add a license, but I want to do that in the feature branch. So, I mean, this is a trivial example, but so let's git branch. Add license. Okay. So now if we go ahead, now we have, so like this is your history, and then we have add license, which is the branch we just created, and master is where it was, and head is now pointing to add license. So that Git knows we're in the add license branch. So now the next thing we need to do is check out that branch to switch to it. So git. So we're going to do git checkout add license. So now it tells us that we're in the branch add license. If we do git log, same history because we haven't done anything yet. So yeah, now we're going to want to go ahead and make the changes that we need here. So I want to add the MIT license. So let me just pull out the MIT license from somewhere and just paste it into a file. Let's go ahead and copy that. And let's just right. So now we have that license file in there. It's git status. So yeah, so on track. You want to add that. Commit it. Yeah. because this is a real repository, and and I want to keep it clean. So now the next thing we want to go over is, now that we have a commit in a separate branch, we want to merge it into master. So yeah, what merge does, it takes changes from another branch and puts it into the current branch. So if we go back here, so we want to switch back to master and git merge add license. And now it's there, and it's in master, which is exactly what we wanted. If we go back here, just to reinforce the idea of git as a graph, we have that going. Notice that add license and master are all pointing to the same node. So now we want to push these changes. What it does, it just copies your local changes and moves them to the remote repository. So now we just do over here, git push, and now it's written on GitHub. And now if I go back to the repository and refresh, bam, there's the commit that I just added now in GitHub. And then, so another interesting thing you might need to do is git pull, like git push, but in reverse. I'm not going to bother showing it. All it does is just change to the remote repository. And if there's other changes in there, it'll automatically merge them if necessary. Another thing you might need to do is rebasing. So let's say you have this history, and you branched off here, and you just made some changes, but master kept on moving, and you want to do that. You want to move your feature branch into master while keeping the linear history. So one way you can do that is with rebasing. And so what it does is literally that. It takes the commits, copies them over here. They will have new hashes because the parents have changed. So like there's actually dangling commits that will get garbage collected later. Another thing, git reset. What it does is it moves the branch pointer somewhere else. So let's say I go back to the demo repository. So let's say we did not like the most recent commit. We want to go back a commit. So what we can do is git reset hard head tilde1. So the tilde notation means so it means go to head and then go back one commit. Right? So now we do a git log, we lost a commit. So yeah, it leaves a dangling commit. So dangling commits will get garbage collected later. It means because you can't get to it from master, there's nothing pointing to it. So it's effectively gone, but not really. So another thing, git reset and git rebase overwrite history. Don't do it. Every time you overwrite publish history, a kitten dies. So think of the kittens.
What if you like it?
Then you have a problem. So either you have an allergy or you have a problem. There we go. So don't rebase commits that are already published. Don't recently, so instead of that, use merge. Don't delete recently published commits with reset. Instead, use git revert, but don't use git revert because your coworkers or whoever you're working with will get mad at you. So git reflog. Git keeps track of where head is at all times. So if you accidentally your repo, you lose a commit, and you want to bring it back, as was the case here. If I do git reflog, there's a thing here for the reset. So what I can do is take this hash, which is how you identify a commit, copy it, git reset hard, and instead of head, we put the name of the commit, and we do git log, or not. I wanted the other one.
Didn't you get it back?
I chose the wrong commit. There we go. Now it's back. The commit things is now back.
That only works until it's garbage collected?
Yes, it only works until it's garbage collected.
When does it get garbage collected?
That is outside the scope of this talk. So, merge conflicts happen when two people change the same part of the same file at the same time. So, let's show a merge conflict. So we want to make a file. Okay, so git branch conflicts. So I just need to create a new branch, and then I want to merge conflict. Okay, so now we have a file 2 with the content merge conflict, and now we want to commit that in master. And now we switch over to, we want to make another change that will conflict. Okay. So now we have two files. I need to commit that, right? Can't type today. Right, so we have that. And so if we look at the, right, so we have that with that commit, master, right, so we have two different commits there. And so if we switch to master and try to merge them, there's a merge conflict. So when you get a merge conflict, you can edit the file. Yeah, sorry, thank you. Git. So we want to edit that. So now you see it'll just put both of the changes in there. So the way to resolve this is to just either pick something or just this is there. Makes less grammatical sense, but whatever. So if we do git status. Now when we commit this, it gives you a merge commit. Now if we look at the graph, there's no red. Colin, how did you get the red back?
Bend the end of the cord.
Right? Right there? No? No?
What are you learning about your
Whatever. So
shell right here? Don't you
imagine there's a line here because there's supposed to be one in the shell, but it shows you that there's the merge is the merge happens here. Drawn better, or not really. We have this, our old masters up here, our old conflicts is up here, and the merge commit has two parents because it's referring to two commits. And now master and conflicts are both pointing to the same commit. So another thing, feature branches you use in the split up development. Again, how you have like one general change per commit, you want one branch per feature, and then you merge into master when you're done. Forking, for working on someone else's stuff. The idea is you develop in a feature branch in a fork that you own. So like you go on GitHub, you hit fork, and then you make changes in your own thing. And then when you're done, you send the developer a pull request, and maybe they'll take your code.
Are pull requests part of GitHub or part of Git directly?
It's part of Git.
No.
No,
Pull requests are part of GitHub.
it's like it's implemented a lot of things. Wait,
Yeah, it's actually
whatever. So yeah, apparently according to the crowd, it's a big thing. But yeah, they're a fairly commonly used thing. You should use them if you want to commit to other people's code. So these slides are available at that link, bit.ly/git from scratch. The lecture notes that I've been referring to are also on that link. And See also Git for Computer Scientists, which is where I got the idea for the talk. The official Git book, Git Workflows by Atlassian, and yeah. Thanks to the usual suspects, John O'Sullivan, Morphy, Goldschmidt, and you guys for showing up and listening.